That's what I mean by pressure. So now what we got to do here is that we got to talk about the unit of pressure. The units of pressure are extremely tiny. So when I think about the units of pressure, what do I know? Well, we know that it involves force. So we need a unit of force. And we know that this unit of force, of course, is a Newton, which we write as N. Then we need a unit of area. And it turns out that a unit of area is meters squared, which we write as m squared. Now, a meter is a big thing. So you're talking like a 3 foot by 3 foot area. So it's big. So if I combine these together, I get a Newton per meter squared. And because this comes up so much, this is known as a Pascal. And 1 Pascal is abbreviated PA. And so what you find here is that 1 Pascal is a tiny, tiny pressure. 1 Pascal is a tiny, tiny pressure. Now remember what we said about pressure, right? It's how much weight is distributed over an area. So here's what you want to think about. So if you have so to get a sense of this, imagine that you have 1 stick of melted butter. And remember, 1 stick of melted butter has a weight of 1 Newton. Okay, maybe I should write that out. So this is a 1 Newton weight. And now imagine that you have a table here. So you have this table, and the table is like this here. So we'll say that this guy is about 1 meter, which is about 3 feet. And then this guy is about 1 meter, which is about 3 feet. So it's not like a super big table, but we could imagine that it's a table nonetheless. Right? So here's what we have here. And then you want to take that butter and you want to spread it all over the top of the table. Right? You're spreading it all over. So 1 Pascal is the pressure from the melted butter placing on the table. So imagine the weight of that, the weight of the butter acting on the table. It's tiny. It's absolutely tiny. So in everyday situations, people encounter hundreds of thousands of pascals. So we do not deal with 1 or 2 or 3, pascals. We deal with hundreds of thousands of pascals. And this is the reason why. It turns out that 1 atmospheric pressure and sometimes people define this as 1 atm. That's actually the standard notation. This, by definition, is 101,000 pascals, which is also equal to 14.7 pounds per square inch. And by the way, this is also 14.7 psi. And if you've ever felt 14.7 psi, you'd be shocked. You'd be really shocked. It is quite large. So what we want to do here is that I just want to show you a couple of values here so you could see what I'm talking about. So what you're seeing here is that automobile tires have 2 atmospheres of pressure. So if you look at a car tire, so let's look at these values. So if I have a car tire has around 30 psi. Well, 30 psi is about 2 atmospheres. So this means here that this is about 200,000 pascals. So that's quite a bit. So when you're thinking about your tire on the road, right, and you're looking at your tire, what you're finding here is your tire, the air in your tire has all these air molecules colliding with the outside of the tire. And as they collide with the outside of the tire, they apply a force, right? They apply a force on the walls of the tire, which gives it pressure. Check out the spiked heels. Look at spiked heels. Wow. They are 10 atmospheres. Now that is something serious here. So this is 1 million pascals. Okay, 1 million pascals. So you could imagine that if somebody stands on your head with all their weight on a single spiked heel, they would apply 1 million pascals on you. And then look at the deepest trench. The deepest trench is 1,000 atmospheres, right? So the deepest ocean trench, well, this is 1,000 atmospheres. Well, guess what? That's equivalent to what? 1,000 times 1,000. Well, that just means here that this is 100 million pascals acting on you. Wow, that is an outrageous amount of pressure.